Toyota just built an engine that almost the entire automotive industry believed should no longer exist. It doesn't run on gasoline, it isn't powered by a giant battery, and it doesn't rely on a hydrogen fuel cell like the Toyota Mirai. Instead, it burns hydrogen directly inside a traditional internal combustion engine, producing the sound, the power delivery, and the mechanical character enthusiasts have loved for more than a century. That isn't a futuristic concept sitting under bright lights at an auto show or an experimental prototype that will never leave a research laboratory. It is a real technology that has already been tested on public roads, pushed to its limits in professional endurance racing, and is being developed by the world's largest automaker. To understand why that is such a big deal, you first have to look at the direction the global car industry has taken over the last decade. Virtually every major manufacturer has announced multi-billion-dollar investments in electric vehicles. Governments across Europe and parts of North America have introduced plans to phase out new gasoline-powered cars, and countless experts have repeated the same prediction. The internal combustion engine has reached the end of its life. For years, that idea has been treated as an unavoidable fact rather than an opinion. Batteries were presented as the future, combustion engines as the past, and anyone investing heavily in piston engines was seen as fighting a battle that had already been lost. Yet, while much of the industry was competing to build larger batteries, longer ranges, and faster charging systems, Toyota quietly began investing in a completely different idea. Instead of asking how to replace the combustion engine, its engineers started asking whether the engine itself had ever really been the problem. What if the real issue wasn't the machine converting energy into motion, but simply the fuel that machine had been using for more than 100 years? That single question would eventually lead Toyota down a path that almost every other global manufacturer had already abandoned. If you've never heard about Toyota's hydrogen combustion engine before, don't worry. By the end of this video, you'll understand why engineers from Detroit, Stuttgart, Seoul, Shanghai, and even rival companies inside Japan have been watching this project far more closely than most people realize. Because what Toyota is attempting isn't another small improvement in fuel economy or a slightly more efficient hybrid system. The company is trying to prove that the internal combustion engine itself may still have a future, provided it burns something completely different from gasoline. At first glance, that probably sounds much simpler than it actually is. After all, an engine burns fuel, so why not replace gasoline with hydrogen and keep everything else exactly the same? The answer is that hydrogen behaves almost nothing like gasoline. Its molecules are dramatically smaller, making storage much more difficult. It burns faster, ignites under different conditions, requires entirely new injection systems, different combustion strategies, reinforced fuel tanks, sophisticated electronic controls, and countless engineering solutions that simply don't exist inside a conventional gasoline engine. Building a reliable hydrogen combustion engine isn't a matter of changing the fuel in the tank. It requires rethinking how the engine breathes, ignites, cools itself, and survives under constant stress. Those challenges explain why most manufacturers eventually chose a different route. Rather than burning hydrogen directly, they focused on hydrogen fuel cells, which convert hydrogen into electricity that powers electric motors. On paper, that approach seemed cleaner, simpler, and easier to justify. Toyota believed in fuel cells too, investing years of development into the Mirai, one of the world's first mass-produced hydrogen fuel cell vehicles. But inside the company's engineering divisions, another question refused to disappear. If hydrogen could power a fuel cell, why couldn't it also power the very machine that had moved humanity for generations? Why throw away more than a century of engineering knowledge, manufacturing expertise, and mechanical refinement if there was even a chance those engines could be given an entirely new source of energy? That question became even more important because Toyota had already experienced what it feels like to stand almost alone against the rest of the industry. When the first Prius appeared in the late 1990s, many analysts predicted that hybrid vehicles would never become mainstream. They argued that combining an electric motor with a gasoline engine made cars unnecessarily complicated, too expensive, and far too unconventional for ordinary drivers. History proved otherwise. More than 2 decades later, hybrids have become one of the most successful automotive technologies ever introduced, and Toyota's willingness to ignore conventional wisdom helped reshape the entire industry. That experience fundamentally changed the company's philosophy. Rather than betting everything on a single technology, Toyota concluded that the future would almost certainly require multiple solutions. Battery electric vehicles would work extremely well in some situations. Hybrids would continue serving millions of drivers around the world. Fuel cell vehicles could become practical where hydrogen infrastructure existed. And perhaps, if engineers could overcome one of the most difficult technical challenges in modern automotive history, hydrogen combustion engines might preserve everything people love about driving while dramatically reducing emissions. Of course, believing in an idea and proving it are two completely different things. Designing a prototype that runs for a few minutes inside a laboratory is relatively easy for a company with Toyota's engineering resources. Building an engine capable of surviving thousands of kilometers, operating reliably under extreme loads, and earning the trust of customers who expect legendary Toyota reliability is something else entirely. The company knew that no presentation, promotional video, or carefully controlled demonstration would convince skeptics. If this technology was ever going to be taken seriously, it had to prove itself somewhere no marketing department could hide its weaknesses, where every engineering mistake would immediately be exposed and every mechanical flaw would be punished without mercy. That is why Toyota made a decision that surprised almost everyone. Instead of keeping the project hidden behind the closed doors of its research centers, the company took one of the most controversial combustion engines of the modern era into one of the harshest testing environments imaginable: professional endurance racing. Because on a racing circuit, there are no second takes, no carefully edited demonstrations, and no place for experimental technology to hide. An engine either survives or it doesn't, and that decision would become the moment when the entire automotive world finally started paying attention. Toyota's decision to race a hydrogen combustion engine wasn't a publicity stunt. It wasn't designed to generate headlines or convince investors that the company had another futuristic project in development. It was born out of a philosophy that has shaped Toyota for decades, a belief that the fastest way to discover whether a technology has a future is to expose it to conditions where failure is unavoidable. Engineers often say that racetracks compress years of normal driving into a single weekend, and Toyota wanted answers that no laboratory could provide. That opportunity came in 2021 when the company entered Japan's Super Taikyu Endurance Racing Series with a specially modified Corolla powered by a hydrogen combustion engine. At first glance, the car looked almost ordinary. It still had pistons, valves, connecting rods, a crankshaft, a gearbox, and nearly everything people associate with a traditional performance car. The biggest difference was invisible. Instead of gasoline flowing into the combustion chambers, the engine was burning compressed hydrogen stored in specially designed high-pressure tanks. For many people watching from the outside, the obvious question was simple: why race at all? If Toyota believed the technology worked, why not continue testing it behind closed doors until it was ready for production? The answer was equally simple: endurance racing doesn't forgive weaknesses. An engine that performs well during a short laboratory test may begin overheating after several hours. Fuel delivery systems that appear flawless under controlled conditions can suddenly become unreliable under constant vibration. Tiny engineering compromises that would remain hidden during ordinary road testing often reveal themselves after hundreds of kilometers at racing speed. Every lap generates data, and every mechanical problem becomes an opportunity to improve the next version. What made the project even more remarkable was that Toyota wasn't treating the hydrogen engine as a finished product. Engineers continuously upgraded the car between races, introducing improvements to fuel injection, combustion control, power output, reliability, and refueling procedures. Each event became a moving laboratory, allowing the development team to collect enormous amounts of real-world information that simply couldn't be recreated inside a computer simulation. Instead of waiting until every problem had been solved before showing the technology to the world, Toyota chose to develop it in public, demonstrating both its successes and its setbacks along the way. One of the strongest supporters of that approach was Akio Toyoda, then president and later chairman of Toyota Motor Corporation. Unlike many executives who rarely appear behind the wheel of experimental vehicles, Toyota personally drove hydrogen-powered race cars under the nickname Moriso. That decision sent a powerful message throughout the automotive industry. This wasn't a project managed from a conference room by executives studying market reports. The company's own leadership was willing to compete in the same cars its engineers were developing, experiencing their strengths and weaknesses firsthand alongside professional racing drivers. As development accelerated, the progress became increasingly difficult to ignore. Toyota improved power delivery, increased reliability, shortened refueling times, and significantly expanded the engine's operating range. Engineers also worked to reduce one of hydrogen combustion's biggest challenges, unwanted nitrogen oxide emissions, while continuously improving combustion efficiency. Although the technology remained experimental, each season demonstrated measurable progress, reinforcing Toyota's belief that hydrogen combustion deserved to remain part of the company's long-term strategy. Perhaps the most important lesson wasn't purely technical. The racing program showed that a hydrogen combustion engine could preserve something many enthusiasts feared the automotive world was beginning to lose. The engine still produced the familiar sound of combustion, still rewarded precise throttle control, still worked with manual and automatic transmissions, and still delivered the mechanical feedback that has defined driving for generations. For Toyota, preserving that emotional connection mattered almost as much as reducing emissions, because the company believed the future of mobility shouldn't require abandoning everything people love about automobiles. While much of the world continued framing the future as a simple battle between gasoline and battery electric vehicles, Toyota quietly began presenting a far more complicated picture. The company wasn't trying to prove that electric vehicles were the wrong answer. Instead, it argued that transportation is simply too diverse for a single technology to solve every problem. A compact city car, a heavy-duty truck, a race car, a construction vehicle, and a long-distance commercial fleet all operate under completely different conditions. Expecting one powertrain to dominate every category, Toyota believed, was neither realistic nor necessary. That philosophy became known as Toyota's multi-pathway strategy, and the hydrogen combustion engine quickly became one of its most controversial components. Critics called it a distraction. Supporters called it visionary. But regardless of which side people chose, one fact became increasingly difficult to dispute. Toyota had succeeded in restarting a conversation that much of the automotive industry had already considered finished. By now, you might be wondering something very simple. If Toyota has spent years developing a hydrogen combustion engine, why hasn't every manufacturer started doing the same thing? The answer is that hydrogen isn't competing against gasoline anymore. It's competing against electric vehicles, and that's a much more difficult battle. Over the past decade, battery electric vehicles have transformed the automotive industry. They've become faster, quieter, more efficient, and in many countries, they receive generous government incentives. Companies have invested hundreds of billions of dollars into battery factories, charging networks, and entirely new vehicle platforms. For millions of drivers, an electric car is already the perfect solution. Toyota has never denied that. In fact, the company continues investing heavily in battery electric vehicles while expanding its hybrid lineup and developing hydrogen fuel cell cars. But Toyota has consistently argued that one technology alone cannot solve every transportation problem, because the world doesn't operate under one set of conditions. Think about long-distance trucking. Think about construction equipment operating around the clock. Think about racing, emergency vehicles, remote regions with limited charging infrastructure, or countries where electrical grids are already under enormous pressure. These situations require different solutions, and Toyota believes hydrogen deserves to be one of them. One of hydrogen's biggest advantages is refueling time. While a battery electric vehicle may require anywhere from 20 minutes to several hours to recharge, depending on the charger and battery size, compressed hydrogen can be refueled in just a few minutes, making the experience much closer to what drivers have known for decades. For commercial vehicles that spend nearly every hour generating revenue, saving time isn't just convenient, it can make a significant economic difference. Weight is another important factor. Large battery packs can weigh hundreds of kilograms, and for passenger cars that may not always be a serious problem, but for trucks, buses, motorsport, and heavy industrial equipment, every kilogram matters. Carrying a massive battery often means carrying less cargo or sacrificing performance. Hydrogen offers another possible path, allowing manufacturers to explore different compromises depending on how a vehicle is actually used. Then there's the emotional emotional side of driving, something that rarely appears in discussions about emissions or efficiency, but still matters to millions of enthusiasts around the world. Electric motors deliver incredible acceleration, yet they do so almost silently. A hydrogen combustion engine behaves very differently. It still revs, still produces engine sound, still works with traditional transmissions, and still delivers the mechanical feedback that many drivers associate with the joy of driving. Toyota has repeatedly said that reducing emissions shouldn't automatically require eliminating the character that has defined performance cars for generations. Of course, hydrogen combustion isn't without its own challenges. Building a reliable refueling network remains expensive. Producing low-carbon hydrogen at large scale is still difficult in many regions, and the technology itself continues to evolve. Toyota has never claimed that hydrogen combustion will replace electric vehicles or become the only solution. Instead, the company argues that the future will almost certainly consist of multiple technologies working together, each serving different markets and different customer needs. That philosophy has become increasingly important because governments and manufacturers are beginning to recognize that the transition away from fossil fuels may not follow a single straight path. Hybrids continue growing in popularity. Battery technology keeps improving. Synthetic fuels remain under development. Fuel cell vehicles are expanding in selected markets, and hydrogen combustion has quietly remained part of the conversation instead of disappearing as many experts once predicted. Perhaps that's the biggest surprise of all. Toyota didn't spend years developing this engine because it expected everyone else to follow immediately. It developed it because history has taught the company that today's impossible idea can become tomorrow's industry standard. After all, people once laughed at hybrid vehicles too. But if Toyota's hydrogen engine really does have a future, one question still remains. Can this technology move beyond racing prototypes and experimental demonstrations to become something ordinary drivers will actually be able to buy? Whether Toyota's hydrogen combustion engine ultimately succeeds or fails will depend on far more than engineering. It will depend on infrastructure, government policy, energy production, consumer acceptance, and one simple question that every new technology eventually has to answer: does it solve a real problem better than the alternatives? History suggests that writing Toyota off would be a mistake. This is, after all, the company that introduced the Prius at a time when many industry experts predicted hybrid vehicles would never become commercially successful. Critics argued that carrying both an electric motor and a gasoline engine was unnecessarily complicated, too expensive, and far too unconventional for ordinary drivers. More than 25 years later, hybrids have become one of the fastest-growing segments of the automotive market, and nearly every major manufacturer now sells some version of the technology Toyota pioneered decades ago. That history explains why Toyota continues investing in hydrogen despite criticism from parts of the industry. The company isn't claiming batteries are the wrong answer. It simply believes they aren't the only answer. In Toyota's view, the future of transportation will almost certainly be shaped by multiple technologies working together, with battery electric vehicles, hybrids, fuel cells, synthetic fuels, and hydrogen combustion each serving applications where they make the most sense. That strategy has also attracted partners. Companies such as Yamaha have collaborated with Toyota on hydrogen-powered performance engines, while other Japanese manufacturers, including Subaru, Mazda, Kawasaki, and Honda, have explored ways to accelerate hydrogen technologies through joint research and development. Rather than treating hydrogen as a competition between companies, many Japanese engineers increasingly see it as an opportunity to preserve decades of manufacturing expertise while continuing to reduce emissions. The implications extend well beyond passenger cars. Heavy-duty trucks, buses, commercial fleets, construction equipment, agricultural machinery, marine transport, and even certain areas of aviation all present challenges where batteries may not always be the most practical solution. These industries often require long operating hours, minimal downtime, and rapid refueling, making hydrogen an increasingly attractive option if production costs and infrastructure continue improving over the coming years. Perhaps the most fascinating aspect of Toyota's project is that it has already changed the conversation, regardless of whether hydrogen combustion eventually becomes mainstream. A few years ago, many people spoke as though the internal combustion engine had no future whatsoever. Today, engineers, policymakers, and manufacturers are once again discussing how combustion engines might continue operating using completely different fuels. That shift in thinking may prove just as important as the technology itself. Of course, significant challenges remain. Building a global hydrogen infrastructure will require enormous investment. Producing clean hydrogen at competitive prices is still a major obstacle in many countries. Governments must decide how much support hydrogen deserves alongside battery electric vehicles, and consumers will ultimately determine whether the technology offers enough practical advantages to justify its adoption. None of those questions have simple answers, and Toyota itself has repeatedly acknowledged that hydrogen is not a quick fix. Yet the company also understands something that has defined technological progress for generations. Major breakthroughs rarely arrive fully formed. They evolve through years of experimentation, failure, refinement, and persistence. The Corolla that first appeared in Super Tycoon wasn't the finished product. Every race, every engineering update, and every new prototype has brought Toyota one step closer to understanding what hydrogen combustion can realistically become. That may be why competitors are paying much closer attention than they publicly admit. Even companies fully committed to battery electric vehicles continue monitoring hydrogen developments because no manufacturer can afford to ignore a technology that might eventually transform commercial transport, motorsport, or entire regions where batteries alone cannot meet every demand. In the automotive industry, today's niche experiment can become tomorrow's competitive advantage remarkably quickly. So perhaps the biggest story here isn't that Toyota built a hydrogen combustion engine. It's that the company refused to accept a future defined by a single solution. While much of the world debated batteries versus gasoline, Toyota quietly kept asking a different question. What if the future is bigger than that choice? Only time will determine whether hydrogen combustion becomes a common sight on public roads or remains a remarkable engineering experiment. But one thing is already certain. Toyota has forced the global automotive industry to reconsider assumptions that only a few years ago seemed unquestionable. People once laughed at hybrid cars. Today, they're everywhere. People are now questioning hydrogen combustion for many of the very same reasons. History may not repeat itself exactly, but in the automotive world, it has an uncanny habit of rhyming. So now I'd like to hear your opinion. If Toyota eventually offered you two cars at the same price, one fully electric and the other powered by a hydrogen combustion engine that refuels in minutes while preserving the experience of a traditional sports car, which one would you choose and why? Let me know in the comments below.